This is the video on addresses. Just like street have addresses, computer has addresses. Instead of a house being at an address, there is a text character or a value at the address. The first address is 0, and the second address is 1. Its address is the offset from the beginning. If the address is 7, its offset from the beginning is 7, but it's the 8th address. Each address can contain a text character. In this example, the characters are ALPHABET. There is a value for each character. The values are shown in the greenhouses. Each of the addresses of 0 through 7. And we need to know that these values of A is 65, the value of L is 76. This is the ASCII code in value for what's at these addresses. To certain addresses, so the address number is not needed. The name of page A is assigned to the base address, so the addresses will be offset from page A. Alright, we're saying here that this is page A, offset 0 is where the A is. The text action is used to place text on the screen. It needs a character count and a text address. First, down here, count 8 at offset 0. Well, here the count is 8, page A, offset 0. The second is count 5 at offset 0. Well, first it said the whole word alphabet. The second time it just says alpha because it just said 5 at page A. Third, count 3 at offset 5. Well, offset 5 is where BET is, so it says here if you say text 3 at page A plus 5, you get BET. Go on. A value can be added to the given offset. The register R is to be added to the given offset. Well, down here we see it's changed, that now it says 8 page A plus R, the value in register R. Well, the first count 8 at offset 0. Alright, R is 0, so this is offset 0, so again it says alphabet. The second count 3 at offset 0 plus 5. Well, here R was set to 5, so the 3 at address offset 5 is BET. And the third, count 3 at offset 2 plus 3. Well, in this one, R is 3. They're going to show 3 things, but it says offset 2 plus the value in R of 3, offset 5, which is BET. Each address can contain a value. In this example, 5, 10, 15, 10, and 5. Here you see the values in houses. The name of list A is assigned to as the base address, so the addresses will be offset from list A. Okay, these houses start at the name list A. The sum action can be used to get the total. It needs the value count and the list address. So here first, we're going to see these sums down here. Count is 5 at offset 0. Well, we come down here, it says count 5 things starting at list A, offset 0. Well, the 5 of these things add up to 45, and that's what it gives us the answer. Second is count 3 at offset 0. Well, if we're at offset 0 again, see it just says list A, but 3 things. It'll be 5, 10, and 15. That adds up to 30. That's what it says the answer would be. Third, count 3 at offset 2. Well, here's offset 2, and it's going to count 3 of them. And here's how that's written, is list A plus 2. And the sum there is 30. We go on. A value can be added to the given offset. The register R is to be added to the given offset. Here they are, where R is 0, 2, and 2. First, when R is 0, the count is 5. The offset is 0. Okay? That's this one, so it adds up all 5 of them, which is 45. Second, R is 2, and the count is 3 at offset 2. So, here we go. R is 2, 3 things at offset 2. Here's offset 2, you add the 3 things, you get 30. And the third, R is 2, and the count is 2. So the offset is 1 plus 2, or 3. And here we see R is 2, but it also adds 1. So it's 2 plus 1 is 3, and it adds the 2 things, the 10 and the 5, to get 15. Main program, and from 1 to 9 subprograms. Below is a list of the 119 registers that the main program can use. The registers with the green background are control registers for the main program. Here they are in green. The control registers are used for, and these are examples, R for rotate, S for size, T for tall, W for wide, X, Y position, etc. A register has only one address, so its name can only refer to one value. It has only one spot in memory, so it can only have one value. Only the 31G, which stands for global, and the 32M, which stands for main registers, can be accessed by all of the programs. That is the main program and all the subprograms. So over here on the left, we see the names that end with the G, M, and also it has the S registers, and it also has the local registers. Over here are the addresses for each one of those registers. Notice in the memory of the computer, they're all contiguous, one after the other. One to 9 subprograms. Below is a list of the 119 registers that subprogram 1 can use. The registers with the green background are the control registers for subprogram 1. The control registers that are used for, this is example, R for rotate, S for size, T for tall, W for wide, X, Y for the position, etc. The register addresses with a yellow background are unique to each subprogram. The address ranges for subprogram 2 to subprogram 9 are shown at the bottom. So here are the names for subprogram 1, but all the subprograms have their unique names. And here are the addresses, though, that are just for the registers for subprogram 1. Down here it says if it would be subprogram 2, these addresses would start at 576 and go to 631. All the way up here to subprogram 9, the addresses for the registers is 2367 to 2423. Variable names. A variable has only one offset, so it has only one value. The variable names can be used in all the program's main and subprograms. The names can be changed to describe the use of the variable. Well, here when they start, they're just called varb1 through varb60. And over here are the addresses for them. Notice again they are all contiguous from 99936 down to 99995. Work list. A work list has 10,000 offsets, so it has 10,000 values. The work list names can be used in all of the program's main and subprograms. The names can be changed to describe the use of the work list. All of the values in the work list are set to 0 when the app starts. The work list values are not saved with the app. Therefore, they cannot be restored back to what they were. And here below, we see at the beginning, all work lists, that is before you start changing them, are list 01 through list 60. And over here, we see their addresses. List 01 starts at 130,000. And you notice these beginning addresses are all 10,000 apart because each work list has 10,000 values. 18 app list. An app list has 500 offsets, so it has 500 values. The app list names can be used in all the programs, main and subprograms. The names cannot be changed. The app list values are saved with the app. They are reloaded when it restarts. So if you place values in any one of these app lists, when your program is saved, those values are saved under that app list, and when it's restarted, they're returned. So here we see what the names are, and they stay this way from list A to list R. And down below here are their offsets, and you'll notice that they're all 500 apart because they each have 500 values in each list. Special lists, they do not have the same number of offsets. The special list names can be used in all the program's main and subprograms. The names cannot be changed. Their values should not be changed. They are read-only lists. The values in a special list are created when the app starts. The special list values are not saved with the app. They are reloaded when it starts, as it says there. Here we have the first one, RNDX at address 74752, and down here it tells you it's 2,000 random digits, that's single value digits. At save there's curve building data. At vector there's vector data. Here's a very important one, the one called RANV, which is random numbers. There are 10,000 random numbers. The numbers go in value from 0 to 9,999. There's also RANC, which is 2,000 random colors. This is the special list. Every program can access them. No renaming. There are 60 work pages. Every program can access them. They can be renamed to describe what the page is about. There are 11 app pages. Every program can access them. They cannot be renamed. The app page names cannot be changed. The app page text is saved with the app. They are reloaded when the app starts. Page 61 is a special page used for pad read and pad write, and I believe also other special purposes that will be described by the action. Alright, down below here in green we see the 8 temp pages. In red we see the work pages. Here in white we see the special page, page 61. And below here we see all of the app pages, page A through page K. Over here we have where their addresses are. Because this is all character data, this is a different set of addresses used for characters. Previous ones are mostly all used for values, all the lists were. Here are the text addresses that go with these names. Alright, this is the end of the video on addresses.